Welcome to our 10th week of school. Before we jump right into today's topic, I have a few questions for you guys. So, what is an angle? Anyone? Yes, sir.
An angle is where two lines meet together to form a degree.
An angle is where two lines meet together to form a degree, correct? All right. That's what you said, right? Okay. Lovely. Anyone else? Anyone else? Yes, sir. An angle is where two straight lines meet at a point to form a degree. Lovely. Please give them a round of applause. Both answers were correct. You forgot to put straight line, but it's correct as well. So, in our previous lessons, we looked at the introduction to angle, correct? We also did the types of angle, isn't that so?
Yes,
then,
sir.
Followed by the other lesson where we touched on construction of a acute angle, isn't that so?
Yes, sir.
Then we did construction of a right angle, right?
Yes, sir.
And then the last class we did construction of an obtuse angle. So, today's topic is pretty simple. It has to do with angle, right? So that's why I asked for the definition of angles, right? So our topic for today is bisecting angles. Anyone in the class heard the term bisecting before? Or know what it means? Take your time. You know, remember, just take your time, gather your thoughts, and try it. Meanwhile, somebody else would like to try?
When the angles are divided.
No, I'm asking for the term bisecting. We're going to take it part by part. We already know what is an angle, right? So we want to know about the word bisecting. We want to know what it means. No, that's the whole thing. I'm asking for the word bisecting. What it means. When you divide two lines? That could work. That definition could work. Yes, sir. To bisect, it means to divide a line into two equal parts. Okay, that's nice. Anybody else would like to add anything to it? Divide a straight line. So, while you guys aren't directly correct, you're not wrong. So the word bisect means to divide into two equal parts. It doesn't have to be a line. It could be, alright.
Fruit.
Yes, it could be a fruit, it could be a shape, or an object. So it means to bisect, it means to divide something into two equal parts. So, we have the definition for bisect, which it means to divide an object into two equal parts. And we know an angle. What's an angle? It's where two straight lines meet at a point, right? So what it means to bisect an angle, put them together. Put the two understanding of the definitions together and tell me what you think bisecting an angle is. Or what is bisecting an angle? Yes, sir. It means to divide an angle into two equal parts. Lovely. Give him a round of applause for that. That is it. So, to bisect an angle means to divide an angle into two equal parts. So, our topic for today is bisecting angles. So, I'll just put up the PowerPoint quickly. Good. Can everyone see properly?
Yes.
Everyone seeing properly?
Yes.
Good. So, bisecting angles is geometric adventure. Good. So, I'll call on one of you to read the little introduction we have here. Who would want? Yes, sir.
This presentation explores the concept of bisecting angles, a fundamental
Geometric process.
geometric process with various applications.
So, the purpose of this presentation or PowerPoint is to explore or give you guys an insight on what is bisecting angles, and it's going to touch on the fundamentals of the geometric process along with some applications for bisecting angles. So, can we go into the presentation?
Yes, sir.
All right, lovely. What is bisecting? What is an angle bisector? All right. Destiny, please read the definition for what is an angle bisector.
An angle bisector is a line segment that divides an angle into two equal angles.
Okay, a angle bisector is a line segment that divides an angle into two equal angles or two equal halves. That's basically what it's saying, right? So, a image, so let us use an image, right? A visual representation. We have a pie. Alright, my circle isn't perfect, but we have a pie, right? This is a complete angle as well, or a 360 angle, right? So, a bisector is going to cut this pie or complete angle into half. Right? So, what would be the half of 360?
180.
180. Let's go there. 23.
1,
2 ones.
2,
Remainder.
1,
Remainder 6. 2 into 16.
8.
Any remainder? No. So,
add the zero.
add the 0. So, there we have it. The half of the complete angle would be 180 degrees. Isn't that so? Good.
So, Barry, speaker? You get the speaker? You know what?
So, can we move forward?
Yes, sir.
Lovely. So, the angle bisector theorem. Miss, please read the first point for me.
Sure. Get an instrument named bisector.
Pardon me?
Get an instrument named bisector.
Any instrument named bisector? I am not sure. I don't think so. I don't think that there's an instrument named bisector. However, I will do some research and I will let you know. For the next class, I will pass that information.
Stop, wait, no.
Yes, it's the line that divides the angle. Right? That would be known as the bisector. Or it could be the line that divides the object into two equal parts. Yes, miss, please read the first point.
The angle bisector theorem states that the bisector of an angle in a triangle divides the opposite side into segments
Proportional.
proportional to the length of the other two sides.
Okay. We have it on the board right here. What it's saying is that, right? The angle bisector theorem states that the bisector of an angle in a triangle divides the opposite side into segments proportional to the length of the two other sides. Let's say, all right, we're going to use this example that is already on the board. We have A, B, and C, right? A, B, let's say AB is 40 mm. 40 mm. It says that the bisector of an angle divides the opposite side into equal proportions, right? So if it's 40 mm, the half of 40 is going to be how much?
20.
So 40 divided by 2, 24, 2, no remainder, so good. Now we're going to measure the line, find the half, this will be here, and we draw a straight line dividing it. So over here, AC is going to be equal to BC, sorry. AC is going to be equal to BC. So if you fold them together, they won't overlap and have any excess. They will be perfect on each other. You know, it's like, pardon?
Like this.
Yes, a piece of paper when you fold it over and you get the perfect seam in the middle. Yes, that could work as an example of the bisector, right? So let's go.
Okay.
Number 2. Sir, please read number 2 for me, please.
This theorem has
Numerous.
numerous applications in geometry, including solving for unknown lengths and proving other geometric relationships.
Good. As you guys advance into the upper level, right, you will be looking at a topic in mathematics. Pythagoras theorem. I think that's the name. I am not sure, right? But when you have the Pythagoras theorem, this same angle bisector, it's going to come in. Angle bisector theorem is going to come in useful for that class, right? You will have like, all right, let me give you an example. I know I'm straying away, but I just want to give you, so C, A, and B. So they would say that A is 60 degrees, and then, let's say here would be 75 degrees, and they would say to find for the unknown, right? So you would have the two, they would give you 2 degrees, and they would tell you to find for an unknown. Or they would give you 2 lengths and tell you to find for an unknown length, or they would give you 2 degrees and a length, I think, to find for an unknown side. But there's always one side which is unknown. But this, by angle bisector theorem, would be coming useful for that. So when you cross that bridge, you get more into it. Please have a seat. Good. Real world example. So, architecture. Angle bisectors are used in designing geometrical structures like bridges, and buildings. Navigation. Bisectors help determine the shortest routes and optimize travel paths. The navigation, they're normally used in, let's say we're using a GPS or
Google Maps.
yes, Google Maps, or whether you're traveling with a plane. And architecturists are those persons that build structures, whether they're building buildings, bridges, a complex, etc. Are there any questions so far, students? So everything that we're doing, you guys understand so far?
Yes, sir.
Sure?
Yes, sir.
In this video, we're going to look at how to bisect an angle. You just need a compass, pencil, and a ruler. We're at a space station on Mars. We want to build a path that is equal distance from the edges of our boundary. We need to bisect the angle to make sure that we are exactly in the middle. Bisect just means cut in half. Put your compass on the point and draw an arc to cross both boundaries. Then put your compass at the first place where the arc crosses the line and draw another arc. Repeat this for the second point, making sure you do not change the width of your compass. You'll end up with 2 new arcs that cross each other. Where these arcs cross is the angle bisector. With your ruler, draw on the line. So we now know exactly where our path has to go. It's quite easy really. You just need to remember to draw 2 sets of arcs, and then you've bisected the angle.
If you like the video, give it a thumbs up. And don't forget to subscribe. Comment below if you have any questions. Why not check out our piece?
Okay, students. So I know the video was a bit fast. Do you guys want me to play it again?
No, sir. No, sir.
Yes? I'll play it one more time. Just.
In this video, we're going to look at how to bisect an angle. You just need a compass, pencil, and a ruler. We're at a space station on Mars. We want to build a path that is equal distance from the edges of our boundary. We need to bisect the angle to make sure that we are exactly in the middle. Bisect just means cut in half. Put your compass on the point and draw an arc to cross both boundaries. Then put your compass at the first place where the arc crosses the line and draw another arc. Repeat this for the second point, making sure you do not change the width of your compass. You end up with 2 new arcs that cross each other. Where these arcs cross is the angle bisector. With your ruler, draw on the line. So we now know exactly where our path has to go. It's quite easy really. You just need to remember to draw 2 sets of arcs, and then you've bisected the angle.
If you like the video, give it a thumbs up. And don't forget to subscribe. Comment below if you have any questions. Why not check out our piece?
Pardon me? Yes, you would have placed the hand out in your book. Not a lot of work. There you go. Turn it over. Alright. Bisecting angle. The first step. Please read the first step for me, please. Good. We'll use the measurement AB equals 40 mm. So, how do we construct an AB line? Our AB line, please. Draw a straight line first. What's the next step?
Place your compass point at point A of your AB line and
No. What's the next step to construct the AB line? Good. Take your ruler and your compass. You place your compass point at the edge of the ruler. Open it to 40. Oh, I hold the ruler wrong. Sorry about that. Place it at the starting, or which is at 0. Open to 40. Then you take that measurement. Place your compass point at the starting of the line. Then you scribe an arc. Without changing that measurement, you go to where the arc intersects the line. And you scribe another arc. Following?
Yes, sir.
And that is how we construct a line. Or our AB line. So we have A and B. What would be the next step?
Place your compass point at AB line and open your compasses to less than half and scribe an arc.
Good. So what we do is place your compass point at A, open to less than half of our AB line, and we will scribe an arc. Good. What's the next step, please?
Changing the measurement of your compasses. Place your compasses at the intersection of the arc and line AB, which is also known as point C, and scribe another arc.
Good. So without changing the measurement of the compass, we place the compass point at point C, and we scribe an arc. Isn't that so?
Yes, sir.
Good. The next step, what will be the next step, please? Draw a straight line passing through the intersection of two arcs and label as point D.
Take your protractor and place the center of the protractor
At point A to measure the degrees of the angle. So, when we finish drawing the so it says to draw a straight line from point A passing through the intersection of the arc. Isn't that so?
Yes, sir.
And we label this point at point D. That is basically a recap of constructing a acute angle. That is what we did that is what we did 2 weeks ago, right?
Yes, sir.
So then we take our protractor, place it at point A, make sure that it's straight, and we measure the degrees. Good, so we have 10, 20, 30, 40, 50, 60. So this angle here is 60 degrees. Turn over the page, please. Good. The next step. Your compass is point at point D,
Open to more than half of
point C, and scribe an arc at the top and one at the bottom. Good. What we'll do, place your compass point at where? Point D. Open to what? More than half of where? Point. Good. More than half, right? What we do, we scribe an arc at the top. The next way we do is we place our compass point at point C again. And we scribe an arc at the where? At the bottom. Like so. Good. So the next step is repeating the same thing that I just. One of the step that we read just now was place a compass point at D, open to more than half of C, and scribe an arc at the top and one at the bottom. And I wrote back the step again at the bottom there. So it's the same step twice, right? Sorry about that. That's a mistake on my end. So now we draw our straight line. from point A, passing through right. A, B, C, D, E. To confirm, we take our protractor, we place it straight, and good. We count 10, 20, 30. So it is divided into two equal parts, 30 at the top, 30 at the bottom, making the whole complete angle 60 degrees. Isn't that so? Are there any questions so far, students? Okay, so good. So what we're gonna do is that we're gonna work one together. Can we do that, students?
Yes, sir.
Lovely. So I'll erase the example, right? And we'll work one as a class. So I'll call on each one, or not everyone. I don't know if there's enough steps for everyone. Let me see. So, yes, we're coming up on the board and work it together. We're going to start with Destiny. Construct line AB. 50 and Destiny and Alfredi will work together in constructing the line. Here's the equipment that you would need, or the drawing materials, and step forward.
Come on. What's Destiny?
So
Working or do on part?
no, we're constructing the AB line. Come on, cooperate, please.
That one's 0. Yes, no. Sorry, you got it, right?
50 mm, 50 mm. Alright, let me come and assist you. So, 50 mm. So we come here, we place the rule in here. Destiny, open the protractor. The rule, sorry, compass. 50. Good, ready. 7 hours. Right, good. Take out that. Place the compass one here. No, raise up, raise up. Let me place it, and then good. Stand that out. Then you label. Label it. Good, excellent job. Give him a round of applause. Come on, we could do better than that. Lovely. What is the next step, students?
Less than half of the square R.
Yes, miss. Come forward. This step is pretty simple, so I will let you do it. Here you go. Let me place a compass point for you. One tap. Come forward. You place your compass and you open to less than half of your AB line. So hold it. You got to create up good. Less than half of your AB line. And then you scribe an arc. You got to start from here. Start from here. Good. Now you got to apply. Good. Place it right here and then turn it up. Go straight up. Straight. Nice. Lovely. Yeah. Good. Give a round of applause. That's good. That's good. The next step. What's the next step?
Without changing the measurements of your compasses, place your compasses point at the intersection of the arc line and line AB, which is also known as point C, and describe another arc.
Heading, come forward. So point letter C. So what we do, we place, without changing the measurement, we place the compass point at C. And describe an arc for me, sir. Describe it. Lovely, give him a round of applause. So, point D, I'll do this part, and then I'll ask load it out. So, right. What we did again, we just constructed another, what type of angle is this? Lovely, it's an acute angle. So now we have 62 degrees. 60, oh, I'm writing 60. 62 degrees. Come, sir, please. So what you're going to do is you're going to place your compass point at B, like so, and it opens up more than half of C. Right? So I'm going to close the compass a little bit, and then you're going to open it. Open it. More than half of C. This is point C. You're going to open it to more than half of this. Down here, down here. Start your arm. Got it? Quite up more. Quite up more. Good. Lovely. Give him a round of applause. Come, sir, please.
Sorry, if you want my extra one, I did it.
What you're going to do, you're going to fix the compass point at C, like so, and then you scribe an eye. Scribe an eye. Try it. Lovely. That's it. Thank you, sir, so much. Give him a round of applause. Come on, we should do better than that. Good. Yes, I know. Come on, miss. You're going to draw the straight line from point A passing through the intersection. Hold it. Let me. Okay. Draw the straight line.
Yay!
Ah, lovely. Thank you guys so much. So, now we have to measure, ensure 10, 20, 30, 31. So we have 31 degrees at the bottom and 31 at the top, which would give us the sum total of 62 degrees. Isn't that so? Lovely. Pardon? Yeah, we divide by second angle. That's what we're doing. We're finding the half. This degree, this angle here is 62 degrees. So the half of 62 degrees is 31. Right? So, this has brought us to the end of our lesson. But before we go, who can tell me what they learned from this lesson? Yes, miss. Alright. So you said I wrote wrong. You said bisecting lines, but which is bisecting angles. So you're correct, right? Yes, miss. Right, correct. You learned to bisect an angle, yes? You learned to bisect an angle. So give yourself a round of applause. So, question, right? So question, I forgot the question I was about to ask, but what is the bisector angle theorem? We looked at it in the PowerPoint presentation. Who can tell me? Take your time. I'll give you guys a minute. Please turn on the speaker for me, please. No, turn around. The butt. Yeah, right here. Yeah, hold it on. Hold it on. Who can tell me? All right, are you guys ready now?
Yes, sir.
What is the angle bisector theorem? Yes, sir.
The angle bisector theorem states that the bisector of an angle in a triangle divides the opposite side into segments and proportional to the length of the other two sides.
Okay, so it's basically dividing an angle into two equal parts. with both sides being proportional or equal, right? Good. So, that is one of the questions I have. I also have another question. Who can give me two real-world examples in which we use to bisect angles? Navigation, lovely.
GPS.
Yeah, that's a form of navigation. That's nice. Anybody else?
Google Maps.
That's the navigation.
Sir?
Yes, architecture. So we have navigation and architecture. Google Maps is considered as navigation, right? So for our next class, I would like for you guys to look up how to bisect a 90 degrees angle, right?